Welcome, .NET friends. It's hard to believe February is coming to a close this week, but here we are, as Frank points out in the chat, warming up the bits. So with the end of February, hopefully comes warmer weather, and we do our best to warm up the bits here on the On.NET Live show. If you're tuning in for the first time, our goal here on the On.NET Live show is to empower all of you, our .NET community members, to achieve more. So who are we and who are we talking to today? Well, I'm your host, Scott Addie, and I'm joined by co-hosts Frank Boucher and Cam Soper. I'd like to welcome today's guest, Divakar Kumar. Divakar, could you please briefly introduce yourself to the audience?
Yeah, so hello everyone. First of all, thanks for having me here. It's such a great honor for me to speak here. And welcome everyone. So I am Divakar. I currently work as a technical architect at Flysoft. I have been in this field for more than like 10 years. But the beauty of it is like if you had asked me a couple of years ago anything about AI related to that, I would have said to you that I literally have zero knowledge on that. Yet here I'm speaking a topic on AI and I'm a Microsoft MVP in AI. The reason why I say this is not to brag about myself, but to give you the confidence developer like us is going to play a crucial role in this AI space, because it is not the data scientist who is going to promote the AI application from the POC to enterprise grade application. It is us like a developer who is going to promote that. So that is what we are going to see today. I'm just going to walk you through the journey that I went through and how I started to build this open source application. And then we will see the code part of it.
That sounds great. And I think, a lot of us are still trying to get up to speed on all things AI. So for me personally, I think it'll be fascinating to hear about your journey and what you've learned. And I'd say let's dig in. Let's get started.
Yeah. So this is just a short intro. So I have already done that. So if you are interested about the blog that I write, so you could visit this link. And also below is the GitHub handle for mine. And that is the same for the LinkedIn as well. So with that, let me give you a brief introduction how I started this journey. So like every one of us, I started interacting with the ChatGPT one day, and I was fascinated by the result that I received from this model. So that is when I started to download a Postman collection, because that is what we have been doing for the entire life as a developer. So we used to interact with the HTTP protocol. So I started to download that, and I made use of this post endpoint for the chance completion, and I sent in some request payload. Then I received a response. So that is how the journey started. So when I was doing that, I came to know about two things. One is in the request payload, you will be sending in something called as a prompt. So that could be a system prompt or it could be a user prompt. So when I say system prompt, it is something that you define a persona for the model. And also if you want to set a goal for the model, you will be doing that in the system prompt. And there is a user prompt where you will be asking the query. So for each of those requests that you send to the LLM, so you will be sending along with these details, the system prompt and the user prompt. And then you will be getting a response back that they call it as a completion. So this is how I started. And then I started to augment some of the knowledge into these prompts, because as you could as you know, these models are trained on the old data, so they doesn't have any information on the new happenings that recently happened, right? And also if it is related to any private information, then also the models don't know about those things. So obviously when you ask about those questions to the model, it will obviously hallucinate. So what you need to do is like you need to provide those information along with the system prompt, then the model will be able to give you a better response. So then what I started to do is like I started to work with retrieval augmented generation. The reason why we went with retrieval augmented generation is we had this kind of a context window. So all these models will be having a context window beyond which you can't dump the knowledge. So once you dump more knowledge to it in the prompt, in the way of prompt. So it tends to give you a hallucinated answer, or the quality of the answer that you expect from the model will not be good. So you always need to make sure that whatever the information that you feed to this LLM is relevant to what you are asking. So that is when this RAG concept came in. So where we will be making use of a vector database, where you will be storing the meaning of those data rather than storing the data as such as we have been doing for our entire life. Now, along with those data, we will be converting them into a mathematical representation. So that will hold the meaning of those data, and we will be storing them in a new type of a database called as vector database. Then, as when we ask a query to the LLM, so we will convert that query as well into the embedding format, and we will be cross-checking with the data that we have in the vector database, and we will be picking only the relevant information from there. Then, if we feed that into the LLM, so it will be able to give you a better response. So this is some kind of a foundational concept that I learned when I started with this journey. So these foundational concepts is never gonna be lost, because this is gonna be there for a long time. And then I started to learn about agents. So that is where the real power comes in. So because now your LLM, the models that you use, is able to think on its own, and also it is able to act with the help of certain tools that you provide with it. When I say tools, it could be a function call with which you interact with the external world. It could be a third party service that you are interacting with, or it could be a monolithic service or a microservice that you have within your organization. So now it has the capability to reach to external world, not essentially directly. So you make a function call, you give um, all the list of functions that you define in your application along with those prompts that you send as a request payload. Now the LLM will be sending back to you which would be the right function to pick up for that particular use case. And along with that, it will also say you what are the arguments you need to call it with. So that is how the flow happens within the agent. So when your model thinks on its own and make use of this tool to perform certain action, then you can call this model to be an agent. This happens with the help of the memory. As we've seen earlier, you need to have a vector database, or it could be any transactional database where you store the data. It could be used for retrieving the last conversation, because now if you feed these LLMs with all the list of previous conversations that you had, it will be having a better knowledge on what you are trying to ask it. So if you are doing this in this way, then you could call your model to be an agent. So this is one of the main concepts that I have learned through when I started with this journey. Then there comes the multi-agent. The reason why we went with multi-agent is the single agent was working fine till we were handling a complex use case. It was working fine only for the simpler use case, but the businesses around us is never going to be simple, right? So we are going to handle complex use cases. So when handling complex use case by a single agent, it was drastically failing. It was not able to handle those kind of complex scenarios. So that is when what we did is we segregated the responsibility to individual agents, and form a multi-agentic framework. So by doing this, what we came up with is like each of these agents have a single responsibility to handle. So when we did this, we got a better result. So that is when there were a lot of frameworks that came up, like AutoGen, QAI, OpenAI Form. So these are different multi-agent frameworks that you could deploy on an infrastructure. And as we seen earlier, the other things remains the same. So now you will be making use of these tools, also known as plugins, and you will be interacting with a third-party servers or monolithic or microservice layer. And on the top, you will be having a database, which is your normal transactional database. Alongside that, now you need to also have vector store, because that is what we have seen in the RAG concept. So now you need to store the meaning of those data to retrieve the relevant information from those databases. But what we are talking about is developers, right? So we always have this developer mindset. So we always tend to focus on these three key areas. So we always want to have high scalability, high availability, a lot of it is, right? So we need to build a solution that is highly scalable, but also at the same time, it should be highly performant. And when we are choosing the service that we want to deploy or that we want to host, or it could be the database, it should be cost effective and it should be highly resilient. So how we are handling the failures, whether we are able to gracefully handle those failures or whether we are able to have implemented the retry mechanism, because now we are dealing with multiple agents. So there could be there could be anywhere there is a failure that is happening. So are we maintaining those checkpoints? Because we need to know from where we need to continue again. So how we are going to deal with that? So these are the several things that you need to think about when you are designing this kind of an architecture. And finally comes the security and monitoring. So if you have done this part, but without the monitoring, you are deploying the solution, you are going to face a hard time when you are going to promote it to production. So you always need to have a kind of a phasing mechanism within your architecture, because that is how you will be having an end-to-end visualization on what is happening behind the scenes. So that is when what I did is I initiated a mail chain with other MVPs in AI, and I started this mail chain with this subject called multi-agent or modular monolith, because from a developer eye, so since I'm from the developer background, as when I saw this multi-agent framework, all I could see was modular monolithic architecture, because you have segregated the responsibility to those individual agents, but in turn, what you are doing is you are deploying it as a single package into a single infrastructure. So if you want to scale up or if you want to have high scalability, now you need to scale up the instance instead of scaling out the instance. So that could work for most of the use cases, but that could also be a problematic scenario for some of the use cases. So I proposed an initial architecture with Azure durable functions, how we could make sure that each of those agents are able to handle scalability to any extent, and it has high performance and also highly resilient, because out of the box you get this resiliency in the Azure durable functions. And sooner or later this got more traction. So there were many feedbacks that I received from the MVP mail chain, and that is when I started to work on this open source project. And there was one another incident with a cosmosdb PG recording meeting. So there we were discussing on design patterns related to cosmosdb, and I was initiating a question around the materialized view pattern. Can't we implement a semantic layer using materialized view pattern? The reason why I brought this topic is to ensure we have a highly relevant information back from the LLM, because it is no longer just a keyword search that you will be making in the database, because that might be working for some of the use case, but you need to also make sure you are querying upon the semanticness of the data. So unless until like you have a semantic layer on top of your transactional data, you won't be able to get a better output from this LLM. So that is when I started this conversation with the Cosmos DB team, and Mark was the product manager of Cosmos DB. So he helped me to go through certain references, and also if I would say this project is in such a stable format. So I would say it is all because of him, the feedback that I received from him and the others from the main team. So that is when I started to build on this durable multi-agentic architecture. So here you could see there is only one difference from the existing architecture that we have seen before. So now all these agents are deployed into different infrastructures. That gives you an ability to have highly scalable environment. That now you have highly resilient environment. Once we look at the entire end-to-end architecture, you will be able to get a better understanding on that. And now you also have this vector store plus database combined together. because I'm using cosmosdb as my database layer. So what happens in the cosmosdb is like now alongside your transactional data, you could also store the vector embeddings alongside it. So you don't need to rely on a separate database just for the use case of storing the embeddings. Now you could store them alongside your single database. You don't need to rely on a different database and have a different data pipeline for it to push those data to those data layers. So all I have is one single database layer, that is Azure Cosmos DB, which acts as a transactional DB and also as a vector database. On top of that, I have a semantic layer, which is going to store this embeddings and along with the transactional data. And also I do have a Microsoft Fabric integration with this application. And out of the box, what you will be getting once you clone this project is different kind of implementation. One is custom multi-agent that I have implemented, and the other one is single agent. You could compare the performance between these two. And also I have made use of certain frameworks that is already out there, like Autogen. And the final thing that I have is the real-time agent implementation, where you could have the speech-to-speech communication with the LLM. So before getting into this architecture, let me know like if there are any queries, so we can address that and then move on to this architecture.
Looking at the questions that have come in, the one that sticks out to me is the one that was at the forefront of my mind. You had a slide where you were talking about cost effectiveness, and one of our viewers asked cost, probably referring to if they were to create a similar architecture, what are they looking at in terms of, let's say, monthly cost, roughly?
Yeah. So yeah, maybe I can explain with this architecture itself. So what I have used here as my hosting service is Azure Durable Functions, which you all might be knowing. It is a serverless-based architecture. So you only pay for the time that you are using it. And as part of the database, I'm using Azure Cosmos DB. As I said before, I'm not relying on a separate vector store. Say suppose Azure AI Search for that matter. What I'm using now is Azure Cosmos DB. Alongside that, I'm storing the vector embeddings as well. So there is a cost effectiveness across the layers that I have implemented in this architecture, right from the deployment, the application layer, till the database layer. You could see the services that we have chosen here is mostly cost effective one.
Got it. And is there, are there, I guess one way to phrase this, if I wanted to create something like this, am I able to use entry level SKUs of these services, or do I really need to ramp up to, more robust SKUs of the various services?
Yeah. So for the POC that I have been building, I have been using this in the consumption plan. So I haven't created any premium plan for this one. It was able to handle very much, pretty much well. And for the database as well. So there is no specific queue I have used, even for the Microsoft Fabric, since we all are on the free trial right now. So I'm using the free trial as well. But after that as well, like even if you are using Q S4 or so and so you will be able to handle much of a traffic with this type of an architecture.
Got it. Frank, Cam, did you want to ask anything?
I didn't want to ask anything. I just wanted to say I really liked that slide earlier that demonstrated how RAG works, right? Because it had never clicked for me before that what is happening there is that that there's a search going on and that the results of the search are being injected into the prompt that gets fed to the LLM. I didn't know that. So thank you, Divakar. That really helped.
I didn't have any questions.
Sure. So yeah, with that, let's see what this architecture from the end-to-end perspective. So for the front end, I have been using Blazor application, and whenever you send a request to Azure Durable Functions, it is kind of an HTTP trigger. If you are familiar with Azure Durable Functions, and Azure functions in general, you should be aware of different triggers. HTTP trigger is one of the way where you could interact with the HTTP protocol. And inside that, I do have different orchestrators. So this is one of the patterns that you could use within the Azure Durable functions. What I have within the Azure Durable functions is kind of a different sub orchestrator. So one that will be help me to handle the travel agency use cases, and the other one is where I am handling the general queries like the frequently asked queries or anything related to my past bookings. So those are handled by a separate sub orchestrator. So how this works is like each of these agents are the individual activity triggers that you could see here. So that allows you to scale up to any extent. And this has been implemented alongside with the help of semantic kernel and for maintaining the prompt files, which we will see in detail once we get into the code, with the help of this cool extension that I came across, which is called Prompty. So with these things, you can ensure that you are building an enterprise grade application, because first and foremost thing that you get out of these libraries and the SDKs is the maintainability of the code will be higher. I haven't seen in other frameworks or in other abstraction layers like the LangChain and other things. But if you are using semantic kernel, one of the main advantage that you get out of it is the maintainability of the code, and also obviously the abstractions that they have built together and the single core that they have, called as kernel. And I do have a separate sub channel, pub sub channel. The reason why I have this is to give the user a better experience, because now once you send this HTTP trigger to Azure Durable function, it will return back to you a 201 accepted result, which is kind of an disconnected scenario. So if you want to have this kind of a mimicking of a request reply pattern, what you could do is like you could have this kind of an pop-up mechanism where once you are done with whatever the activities that you are doing with these multiple agents, you could send a notification to this sub channel, which is being subscribed by your front-end application. So then the user will be knowing that, okay, so this is what the conversation looks like. And the chatbot experience won't be interrupted just because you have a disconnected scenario in your backend application. And the next thing is with the help of change feed, I am building a semantic layer. Change feed is a concept where whenever you store a data into the cosmosdb, there will be a CDC mechanism. So the change team, whenever there is an insert or update happens on the logs of the database, so it will intimate you, and the Azure durable functions, the Azure functions that I have for this will be listening onto this change feed trigger. And with that, what I do is like I fetch the information from a lot of different areas. It could be within a single database. I could gather the information from different database, or it could be different microservice where I fetch the data and I feed them into this semantic layer, so that whenever a person is asking a query upon certain things related to the travel agency, I was able to handle that seamlessly with the help of the semantic layer rather than directly pulling that information from a single table. Because within a single table, you could have your column names that is only understood by you. Because we have this practice of having any column names, right? But it should be understandable to the LLM. What kind of data are you storing in that specific column? So for that, you need to always have this kind of a semantic layer, so that whenever you are doing this natural language to SQL conversion, it will have a better result. And finally, I also have a database mirroring concept, which is uh, something a new kid in the town. So with the Microsoft Fabric, what you could now do is like you could just mirror the data that you have in this Cosmos DB. You don't need to have a Synapse link for just to perform the analytics. You just need to mirror the data, and once you pull those data into the one lake, there you could use a number of services like data warehouse, data lakehouse. You could also use Power BI to visualize those data. So that is what I have been using here as well. So I believe I covered most of the area here. The other integrations that I do have is eager integration. So I was talking about the monitoring aspect, right? So you need to have this monitoring aspect. For that, I do have this tracing mechanism so that you could visualize an end-to-end flow right from the start of the request a user is posting to the LLM till the response that it is generating, all the multi-agentic response in between you have within those agentic conversations. So everything is being traced by this eager monitoring tool. You could swap this with any monitoring tool that you have, because at the end of the day, if your APM is supporting OTLP protocol, then you could make use of Grafana or Prometheus, any sort of APM. And that's it with the object structure. Maybe now we could see the code walkthrough of it.
Yeah, let's see some code.
So let me first show you how the structure looks like. So once you clone this repository, you will be able to find certain folders I segregated. So this one is where I store my pipelines, and the main the solution structure is inside this durable agent. So here is where our Azure durable functions reside. And alongside that, we do have the services. Just to mimic an enterprise grade application, obviously you will be having a microservices architecture. So to mimic those, I do have everything in the single repository. So here you could find I'm currently having 4 microservices. One is for the booking service, the other one is for flight service, the one with for user service, and the weather service. With that, let's see some code inside the durable function. I just want to cover a few parts in that is related to the semantic kernel, how it helps us to build a better code, and then I will show you how the prompty extension is helping you to maintain those prompt files. Then we will see like the code that we have for the agentic implementations, and then we will also see how the open telemetry is being integrated. So first, let's start with the OpenAI services. So the beauty of it is like instead of directly tightly coupling any specific AI provider, what you could now do is like you could have an abstraction layer on top of it that is being provided by this iChat completion service. This is being used whenever you are interacting with the model. Chat completion service is the one that helps you to get back the response in the text format. And there is one another interface that is called iText embedding generation service. This allows you to generate the embeddings out of the text that you pass it to it. This is where we have seen in the rack. So you need to convert that data into embedding format. So this is where I have been using these 2 interfaces. Right now, I do have only one implementation of it, Azure OpenAI Chat Completion Service. This could be multiple implementation as well. So you could then have a runtime sequence. So you could dynamically switch between those implementation in runtime. And also, I do have a specific place, which is kind of a single point of contact. So this is the another layer that I have internally. So here, why I have this layer is to have a better abstraction on top of whatever we have already. Since now we are going to interact with multiple agents, each of those agents could use different models. So you could have a specific logic, business logic around here, because whenever you are calling this from a specific agent, say suppose this has been called from a booking agent. So you could have a business logic around here to switch between different models. Like you just need to specify which model ID you want to refer here, and then you could have a different settings for that specific agent around, and you could have a different temperature settings for that agent. So this could be different for different kind of agents. So that is the level of flexibility that you will be getting out of the semantic kernel. So now you don't need to go to multiple places just to plug in these things. All you need to do will be in a single place. So that is one example that I could show you with respect to the semantic kernel.
One thing,
Maybe now.
if I could chime in here, one thing that I really appreciated, I think it was in your program CS file. I wanted to point something out there that you're actually using the Azure Identity Library, specifically the default Azure credential, to avoid doing key-based authentication. You're taking that a step further, and you're doing token-based authentication to enter ID, which is great to see.
Exactly. So what we have been using here is the manage identity. So once you deploy this into the Azure durable function, you need to set the respective RBACs for those Azure durable functions. But if you are executing this from your local environment, you just need to make sure whatever the account that you are currently logged in with this Visual Studio has those permissions as well to interact with this model. So that when you are running this locally also, you will be able to make use of this manage identity. So there will be a seamless experience that you will be getting within the local environment and also with the deployment environment. Okay. So with that, let me go to this prompt. For that, let me expand this agent six folders. So in each of those agents, I do have a prompty file. So if I give a glance on this one, so you could see this is essentially a prompty extension file. I will come to a bit like how we are connecting or integrating this with the semantic kernel. But here, whatever we have seen earlier, like the system prompt or the user prompt, those are the same concept that you are providing in this prompty file. Instead of you just dumping everything in the HTTP client alongside your request body, you now have a different mechanism, like because now you have a separate file for holding those information. So for the booking agent, I do have this separate file, and there are different prompt templates. The templating language could be different. Here I believe I am using liquid prompt template. There are different templates like handlebar templates as well. So by the templating language, what I mean is like in the runtime, these values will be replaced. Anything that has been surrounded with the curly braces. So these values will be replaced at the runtime by the kernel, by the semantic kernel for you when you are providing it with the arguments. And here you could have lots of business logic as well. Like you could have a for loop, you could have an if condition, anything you want to have, you could have this in this promptify. And also you could mention that the output should be in the specific format. So it will do on its own.
I have a question here for you. So I see the extension on this file is .prompty. Does Visual Studio provide any kind of assistance or colorization when you use that extension?
Yeah. Sadly, I have been using Visual Studio for my development, but then you could use Visual Studio Code. So you have this prompty extension here. To download this extension. So this is the prompty extension that I was talking about. Once you download this, you could now see this Visual Studio Code has recognized this prompty file. It has attached that with the prompty logo, and you also could see this has been intended and the things has been highlighted.
Yeah, that's much.
So Visual Studio Code is There is one more thing. Good thing about the prompty is like you also could preview now the markdown file alongside like how you preview the markdown file. So that is same as prompty file. So I suppose you have some static images here. You could just visualize them in the prompty file in the preview form. And that doesn't end there. You could also run it before you are trying it with the deployed version, so that it helps you to work with the local environment. So if I just click on run, so what it is going to do is like it is just going to use the local credentials to make sure that is having the manage identity permissions, and then it is trying to run this entire prompt file. Since I don't have specific information on these user information, let me show you that. I'll go to the verbose mode. So here you could see, right? So the role is in system, and the content here, it has nothing replaced my the curly braces because I haven't set it. I haven't set these are the values that you need to bind it with. But if you are doing that and you are running this from your Visual Studio Code, you could know the response that you are getting out from LLM prior to you even trying this out in the deployed environment. You just can handle this with a single Prompty file as well. You don't need to have your entire set of .NET code along with it. You just need to have a single Prompty file and you are good to go. So those are some of the features that have been provided with the Prompty file. So going back here, let me go to this Prompty service. I do have an abstraction for this one, just to have everything in a single place. So what I do here is I will be reading all the contents from the Prompty file, and I will be converting that into the prompt templates that I was saying before. The liquid prompt template is what I am using. So you could use any prompt template from factory that you are familiar with. And here you could see while I'm rendering, I'm passing the kernel. Along with that, I'm passing the arguments as well. So these are the runtime variables that you will be replacing with those curly braces. Then you will be sending this to your whatever the calling application is. Okay, suppose this is one of the calling point where I'm using this Prompty service. Here I'm just mentioning it as which prompt file it needs to call into, and then I'm just passing the kernel along with it, and I'm also passing the context, each of those runtime variables. The context has been replaced with this user query, the user ID, history. We are also passing the chat history so that it better knows about the previous conversation that we had with it. And alongside, we are passing the other information related to the current logged in person. So with that, let me show you a bit around the open telemetry maybe. Okay, let me start from the program downstairs. So open telemetry, so you have two different ways of instrumenting it. One is automatic instrumentation that you could use with certain libraries you inject into your services. You will be able to get the traces out of the box for you, but we are the developers, right? So we always tend to have the flexibility among ourselves. So we tend to do it manually. So that is what I have done in this open source project as well. So that gives you a better flexibility because right now, since we are handling with multiple agents, you need to make sure what kind of token that you are consuming at each of those agents, each of those toll calls, because you need to always make sure you are within the context window that we have seen at the start of the slide, right? So you need to ensure that you are tracking those metrics. So if you are using automatic instrumentation, I believe you won't be able to capture those things. But then you need to make sure that you are capturing this using the manual instrumentation. So what I did is here is I have used a Tracer Provider Builder SDK, and I'm using OTLP protocol. As I said before, whatever the APM that you are using, if you are following this OTLP protocol, which is a standardized protocol that they are using for the APM, then you will be able to export them, export whatever the logs, whatever the metrics, whatever the traces that you push from these applications to those OTLP collectors. And alongside that, I'm also using Azure Monitor Trace Exporter. This works in a separate way than the OTLP exporter. So we do have a separate SDK for it, with which you could directly connect with the Azure Monitor. And you need to specify the name of the service that you are currently handling. This is Trace service. And you could set sampling. It could be different for the production environment. Right now, I'm having always on sampler, so it will try to give me better picture because I'm just going to dump all the verbose into this APM. So that is how you will be registering the open telemetry SK. And also I do have the metrics provider. So along with that, let me show you how you could do this manual instrumentation. So here you could see there are different tracing handlers I do have. One is for the activity tracing handlers. Other one is for the HTTP interceptors. HTTP interceptors is something will be called when you are using right before you are using the HTTP client. So whenever you are interacting with a third party, whenever you are interacting with the microservices, you need to make sure that you are binding those requests alongside with the open telemetry context, so that the microservices, once they are receiving that request, they will be able to know, okay, this is the correlation ID that I need to bind with. You will be able to get the end-to-end information. Let me show you one example. So activity trigger tracing handler is one thing that I have created here. So what I have done here is, so here I'm kind of getting the parent tracing handler. So there are three things that you need to get capture from your parent span that you are creating, with which you will be able to create a flow. So one is the trace, the other one is the span ID, and the third one is the trace flag. So with these three parameters, what you could do is like you could create a child span. So this child span, when it is created span, now you are trying the subsequent child span with the parent span. Now you could see the visualization of the end-to-end flow. And then these are the sets of things. How I bind this is like I do have this way of delegate handler that I'm using here. Let me show you that. This is one of the agent that booking agent. What I have here is I have this entire business logic wrapped in a delegate, and then I'm using the tracing handler that we did before and executing the tracing handler with the help of this. So what happens is before it is trying to hit the basic the business logic, I'm trying to bind the child span with the trace IDs so that you get this visualization. Maybe if I could run this application, maybe we could get a better understanding on what we are about to see. So let me run this application. I'm already running the eager instance, which is an exe format that I downloaded. So you could also use Docker instance for that. Let me bring up this one.
So while you're working on that, the viewers might be wondering, hey, where do I see this code? Is this available on GitHub for folks to take a look at?
Yes, it is. Maybe I could have the link here.
Yeah, if you put that in the people tab, we can get that to the viewers.
You read my mind,
Okay.
Scott.
Thank you.
Prompty is super cool. I learned about, like, I knew the name, but I learned like really how it was, what it does at the end of January during the AI tour. I was doing a workshop, and it's pretty cool.
Sometimes when you run locally, the Azure functions that will try to do it.
Wonderful.
So for folks that want to follow along at home and kind of dig deeper into what you're seeing here, take a look at the GitHub repo that I just shared. And yes, Jeremy, this is something you would have seen Seth demonstrate. I know Seth has spent a lot of time working on Prompty.
Yeah, now it's good. Okay, there we go.
Running live demo while streaming. Woo-hoo.
Yeah, that's always challenging. So yeah, so this is the application that I was talking about. Let me pick one of the earlier conversation that we did. This one. Yeah. So I was asking this LLM to plan me a trip from Chennai to Goa on so and so day. So what it did is like you could see the interactions at the right hand side. So first it tried to communicate with the flight agent to look at what are the flight details available for this specific date. So it found two specific dates for that, for the departure and for the return flight. And then it tried to initiate a call to a weather agent. So there it gets to know about the weather of those different departure times. And then it tries to give you a better uh, time for you to go to those locations. So it then finally reached out to the booking agent for you to book the trip. So these are kind of a multiple agent interaction that is happening behind the scenes. So what we will do is like let's initiate one call. So let's see how it goes. Yeah. Since everything is in the serverless mode, as I said before, those services will be on the sleep mode now. So it will take some time to wake up. So hope it shouldn't take more time. Let me open the eager UI as well. Okay, so yeah, now it is interacting with the flight agent. So now you could see I'm just keeping the user interactive because now you will be able to see like what are the interactions that we have behind the scenes. So each for those loading screens, what I used is like I used to give the information to the LLM that these are the destination that this particular user is trying to travel to. So it will just pick one particular cool thing about that particular location and it will show you here so that you will be having a better user experience. So now it is reached to the booking agent. That is our final agent. So once it's done sort of interacting, so you should be able to get the confirmation mail as well. So that we will see in a bit. Cool. So now the booking has been done. So as before, you could see there were three agents that was involved in this entire conversation. And let us see if this has been captured in our OpenTelemetry. Cool. So now you could see the end-to-end flow has been captured here. One. So right from the place where we initiated the web call, so it traveled through the orchestrators. As I said, we have different orchestrators for one for the travel bookings and the other one for handling the frequently asked queries. So it reached out to the route orchestrator. It knows which orchestrator it needs to pick into, and that is how it went into the travel orchestrator. So then it found flight agent is the first agent that I need to ask, which would be the right flight for me to pick up. And then there are different plugins that I'm using internally here. One is, let me zoom it a bit. Hope this should be better now. So here you could see inside the flight agent, we made several tool calls. This is what we have seen in the agent slide. So when your agent is able to think on its own and perform action based on the tools that you provide, then you could call your model to be an agent, right? So this model has used airport code plugin, so that is what it could pick up. So you could see the response data here as well. It tried to call the departure city. It found that departure city is the Chennai and the destination city is Goa. And the response data also you could see here. So now you could have an entire picture how it is happening, right? So here you could see it has reached out to the flight listing plugin. So now that we have found the airport code for that particular destination, the next thing that we need to do is like what are the flights available for those destinations. So it tried to call that endpoint, that tool, and then it started to interact with weather agent. So here we have multiple plugin calls to get all those weather details from each of those destinations. One other cool thing that I did here is, so along with the response data, now you could also see the token consumption here as well. Right in your APM, you could also see how much token you are consuming, so that you are always keeping on track of it. So just for the flight agent, I'm using this much of total tokens that has been consumed. And this is for the weather agent, and the final thing that reached to the booking agent. So you get to know about the entire workflow with the help of this open element. Maybe if you have any queries, we can address. If not, yeah, I believe that's all I had for this demo.
Any questions in the chat here? I see we're trying to find the correct Scott. I'm trying to handle the ambiguous Scott exception over here.
Was it the great Scott, the greater Scott? I forgot. There was a joke once where they were.
I'm seeing it.
So I guess I have a question if there aren't any. I know in your architecture slide, you showed cosmosdb. I'm wondering which API specifically are you using in cosmosdb? Is it NoSQL or something else?
Yeah, that's a great question. Since I haven't shown that, let me show you that as well. I'm using NoSQL. So there is a vector search capability that has been introduced in the NoSQL as well, and there are other APIs right now has this capability. One is Mongo Vico, and the other one is even in the PostgreSQL you do have this capability of interacting with the vector search. But what I want to show you is natural language to SQL service. So this you could find it in this source code. So what I did here is like whatever the query that you ask to the LLM, what I do is like I convert those natural language into a SQL query. So because certain queries will be handled by the keyword search, and certain queries will be handled better with the help of the semantic layer that we built. So what I'm doing here is converting the natural language to the SQL. What I'm using for that is there is an endpoint. So this is something that you could see in the Cosmos DB. If you are familiar with the Cosmos DB, once you open a specific document, you will also see a SQL query that is attached to it, where you could prompt with natural language. And if you could just drill down into the developer tools, you will be able to see like what are the network calls that is happening behind the scenes. That is how I built this abstraction layer for my own purpose. You could also build this on your own by specifying each keyword what it means, like whatever the collection you have. You just need to specify these are the properties that you have inside your collection, and these are the responsibility of each of those properties. Then you could also build the NL to SQL layer on your own. I'm just making use of the Cosmos SQL API endpoint, converting the natural language to SQL. And there is one thing that I'm using with the help of Azure durable functions. Let me show you that one. I'm using fan out and fan in pattern. So as I said before, Azure durable functions comes with a lot of different packages. One is that you will be able to split the request to two different services, and these two different services will be handled parallelly at the same time. So what I'm doing here is I'm making a call to semantic agent where we convert the natural language to the SQL, and I send a query to a vector search agent. So this is where you store the data in the embedding format, and there is a repository that will handling this particular task. So both of these tasks are handled at the same time, and I do have a consolidator agent. So I'm fanning in here with the consolidator agent. I'm just gonna ask it to respond back with a better response, because let me show you that. Say suppose so this is one of my query that I earlier asked with the LLM. Have I visited any beach destination in the past? So this uh, could be handled better by the vector search agent, because you are now holding the semanticness of the data. So all you are sending to this database is just the destination name, which is Goa or Chennai. But the LLM knows Goa is bound to be a beach destination, so it tries to say that yes, you have visited a beach destination in the past. But you could see here, semantic agent, it is failing in this aspect. So that is the reason I'm sending two requests that is parallelly happening. It is kind of a hybrid search that is happening behind the scenes to give you a better response. There are different places where semantic agent will be playing a better role than the vector search agent. Maybe I can pick this one. I'm just asking it, can you list my past bookings? So your vector search algorithm could be having top K response or something like that, which will be just showing you two or one response, right? So, but then your natural language to SQL query, what it does is it does the keyword search, and it will retrieve all the past bookings for you, and it will be able to explain you what are the past bookings that you did. So these are two places where I have used cosmosdb. You could also find this implementation here. So I will be triggering two different agents. One is the semantic agent. Inside this agent, I do have different plugins. So under the plugins, you could see Semantic Layer plugin. So here I'm getting the SQL query from the Semantic Layer. And there's one more plugin. Here I'm doing a similarity search. So there is a service that I call to. So here you could see, right? So based on the similarities between the query that you ask, whatever the query that you send to the LLM, that will be converted into the embeddings, and it will be cross-checked with what are the embeddings that you have stored in your database, and you will be retrieving top n from it. So here I just have one record to be returned back from this repository. So it was failing in those cases where it was not able to get all the data from the database. So you always need to have this kind of an hybrid search within your organization so that you could get more relevant information out of it.
Very interesting.
Awesome. Yeah, the lots of good chatter here. I guess some folks asking what's durable functions. I see that was addressed already. Overall, lots of praise in the chat. Folks like what they see. Very well put together. But with that, we are at time, unfortunately, for today's show. I did want to give a shout out to all of our viewers for spending the last hour of your day with us. We really appreciate your support here and tuning in to listen in to what our guest has to share. Divakar as well, huge kudos for sharing your knowledge here and this awesome application that you've put together. I know I learned a lot. Hopefully others can say the same. As a reminder, today's show was recorded. We record all of our shows, and you can find those out at dot.net/live. Just navigate there in your browser. And we hope to see you next time. Thanks again, everyone. Bye.
Bye.
And sorry about that. It's not playing.